standard results, what do I mean by that? Well, here are a few, and you remember those from last week. We looked at one or two standard results. So if I want to integrate something like this, what I'm doing is I'm trying to get the problem I'm trying to solve to look like that standard result. And that sometimes is not easy, and that's probably the hard part of using these things. Once I've got it to look like a standard result, then as soon as it looks like this, A is going to be this number here, and so long as that's x, whatever x is, that will be this value here. So it's the angle whose sine is x over A plus C. And as I was saying last time, if you want to see how this standard result is arrived at, then have a look in the textbook. Here's two more standard results. And for those distinction type questions, you might be asked to maybe try and have a go at seeing how one of these is arrived at. And if you have a look at it, actually, it might look a bit awkward to start off with, but once you've got the idea of how they work, it's not too bad. Here's an example of one where we want to use a standard result. And the standard result we're going to try and use is this first one we had here. Sorry, the second one, this one. So x, what's x? Well, if we look at this, in fact, it's not x squared, it's 4x squared. So what we have to do is think about making this something squared. So we let 2x be inside a bracket. If I square that bracket, I'll end up with 4x squared, which is this. So what I do is I call that this. So I can say I've got something squared. And then I let u equal 2x. So that we've got the integral between 1 and 0 of the square root of 9 minus u squared. But we're still integrating with respect to x. We need to be integrating with respect to u. So can you remember what we might do next? I've got to change this. This has got to be du to be able to do the integral. So what do you remember what we do to change this? Is this substitution idea? Right, we differentiate this. Good. We find out what du by dx is and then change it. So we have that. Du by dx equals 2. So dx equals du over 2, this idea of algebraic substitution that we've looked at before. So now the integral becomes the integral between 1 and 0 of the root of 9 minus u squared times du over 2. The 2 can come outside the integral. And so now we've got half integral between 1 and 0 of the square root of 9 minus u squared with respect to u. And this is a standard result, which is this one here. So a squared equals 9. If we look at this example, a squared equals 9. So a equals the square root of 9, which is 3. So we know that a equals 3 and u equals 2x. So then we can put in the substitute. We can use this standard result where a equals 3 and u over 2 root 9 minus u squared, and then we remember that u equals 2x. So finally we get this, and then we can put the limits in, finish it off. Okay, so it's that sort of idea of getting our integral to look like a standard result, and that's what I mean by that. The standard result is just x squared. We've got 4x squared. So what do we do about that? We make sure we've got something squared, and that will now be our x. So we call that u, and